So if the integers v and w are both positive, is v over w is an integer. So really, whenever you get something like this, I always find it handy anyway to rephrase it as is v a multiple of w? So the statements. Statement 1 tells us for every factor n of w, which really just says for every factor of w, that number is also a factor of v. Another way to restate that would be every factor of w including w, because w is a factor of w. Every factor of w including w is a factor of v, which means that v is a multiple of w and statement 1 is sufficient. V over w would be an integer, so it's not 2 on its own and it's not the insufficient ones. Statement 2 is less helpful. I just sort of tipped my hand and told you that it's less helpful. Anyway, for every prime factor of w, that number is also a prime factor of v. The trouble we get into is that it doesn't exclude other prime factors of v, just that all of the prime factors of w need to also be prime factors of v. Or they can even have the same prime factors but in a different distribution. So for example, if w is 18, it has prime factors of 2 and 3, and if v is 24, also has prime factors of 2 and 3, but v is not evenly divisible by w, so it's not an integer. But clearly we could pick other numbers where it was. We could say v equals 36, and still have factors of 2 and 3, and it would. So since it's sometimes yes, sometimes no, statement 2 is insufficient. A alone is the answer.